Greetings of the day to all. I am Shikha Kansal and we will be talking about correlation analysis and its concepts. What is correlation? What are the different factors which affect correlation? What are the different kinds of correlation? We will be talking about these topics in detail in this PPT. So, if two quantities varies in such a way that the movement in one is accompanied by the movement of another, these quantities are called as correlated. For example, the price of commodity and the demand of commodity. If we take an example of commodity like onion, a simple commodity which every house which every house is buying. For example, the price of commodity onion is increasing, we will see that the demand of the commodity onion is decreasing. Therefore, we can say the demand and the price is correlated when we talk about a commodity like onion. The degree of relationship between the variables under consideration is measured through correlation analysis. The degree, that means what kind of relationship, how much they are dependent upon each other, how much the price of onion and the demand of onion is correlated with each other. This is studied under a factor, under a term called as correlation analysis. Now, the correlation analysis is referred to as a technique used in measuring the closeness of relationship between the variable. That means, by the help of correlation analysis, we will be studying the closeness between the price of onion and the demand of onion. This is showing us the closeness of these two variables. That means, how much they are affecting each other, what is the level of the effect, what is the level of closeness between these two variables. The measure of the correlation is called as correlation coefficient or correlation index. The correlation analysis is a statistical device which deals with the association between the two or the more variables. Now, we have different kinds of correlation. For example, the first one is a positive or a negative correlation, in which it depends upon the direction of the change of the variable. That is, if both the variables are varying in the same direction, for example, if the price is increasing and the demand of the product is also increasing, this is called as a positive kind of correlation. If one variable increases, the other also increases, or we can say if the one variable, that is price, is decreasing and the demand is also decreasing, this is for the product 2. This is called as a negative correlation. The first example here, when P is also increasing and the demand is also increasing, in case of product 1, it is called as a positive correlation, whereas when P is decreasing and demand is also decreasing, it is called as a negative correlation. This dependency depends upon the direction of the change of the variable and both are increasing, this is one type, and if one variable increases, the other also increases, or we can say the relationship between the two is that the one variable is decreasing, the other is also decreasing. So, this becomes a positive correlation. For example, we can talk about hard work and success, we can talk about intelligence and achievement. That means, if a person is working hard, then he is supposed to get success. So, how the hard work of a person and how the success are correlated to each other, what is the interdependency, what is the relationship between the two, it is called as a positive correlation. Whereas, if the variable varies in opposite direction, or one increases the other decreases, or vice versa, that means if one decreases the other increases, then the relationship between these two variables becomes a negative correlation. It becomes a negative correlation. For example, we can talk about if a person is anxious and how he is performing. If he is anxious, then his performance will go down. The anxiety in a person, it increases and the performance, it decreases. But if the person is not very much anxious, the performance will start improving or start increasing. Thus, this kind of relationship, when one is increasing and the other is decreasing, this kind of relationship is called as a negative correlation. For example, when we are talking about a positive correlation, here we have taken a small table in which the x axis shows us the different values. We can say here the price and this is the demand. The price shows 10, 12, 15, 18, 20, 22. We can see here onto the x axis we have we have plotted different points which talks about the price of commodity are 10, the 12, 15, 18 and 20, 22, and onto y axis we have taken as demand. The first is 15, then 20, 22, 25, 37 and 42. Therefore, we can say as the price of commodity onto the x axis are increasing, the demand for the commodity onto the y axis is also increasing. This is telling you about the positive correlation. What about the negative correlation? The same kind of example if we talk about, we have taken a small table again in order to explain you what is a negative correlation. It shows you that if we are taking price of commodity onto the x axis, that means this is the price where it is 20, 30, 40, 50 and 60, and onto the y axis we are taking demand y as 40, 40, 30, 22, 15 and 10. So, here we can say that when we are plotting this graph, as the price is increasing, the demand for the product is decreasing. That means they have a inverse relationship. This kind of relationship is called as an inverse relationship, where my demand, where my graph is going down, where one of the commodity, where one of the factor for that product is increasing and the other is decreasing. The price is increasing and the demand for that commodity is decreasing. This is called as a negative correlation, where the relationship between the two factors are inverse to each other. The next says simple, partial and multiple correlation, where two variables are studied, then it is a problem of simple correlation. When we are talking about only two variables, that is price and demand. If we take an example of only price and demand of onion, then this is called as a simple correlation. When two or more variables are studied for the same product simultaneously, then it is a problem for either a multiple correlation or a partial correlation. For example, when we study the yield of rice in relation to the amount of rainfall, we are studying the price of rice, the yield of rice in relation to the amount of rainfall and fertilizer being used. That means yield of rice onto one side, and we are talking about two more factors for yield of rice. One is rainfall and the other is fertilizer. And we are saying when we are talking about two variables, this is called as a simple correlation. When we are talking about more than two variables, two or three variables, then it is either a multiple correlation or a partial correlation. Here we are taking two we are studying the relationship between three variables, the yield, the rainfall and the fertilizer. So, it is an example of a multiple correlation. Then what is a partial correlation? Now, if we study the same problem, that means the yield of rice, but we are keeping the other factor constant, we are keeping one of the factor as constant. That means we are studying the same problem, that is the yield of rice, taking one or more variable, but the influential factor is only one. The influential factor is limited to only two. Then it is called as a partial correlation. For example, only the yield of rice in relation to the fixed temperature, we are fixing temperature, we are fixing rainfall and fertilizer used, then it is a case of partial correlation. Here we have more factors, but we are talking about, we are fixing few factors and we are studying about the yield of rice taking only 2 factors, we are keeping the other factors constant, then it is called as a partial correlation. Now, we have the linear and non-linear, or we can say curvilinear correlation. The distinction between linear and non-linear correlation is based upon the we can say the constancy of the ratio of the change between the variables. That means, how much the variation is there, what is the ratio of the change of the variables. When we are talking about the ratio, then it is a linear or a non-linear correlation. Therefore, if the ratio between the change of the two variables is same, when the ratio of the change of the two variables is same, then it is called as the linear correlation. For example, here the ratio becomes 1:7, or we can say 1:7. Here onto the same, when the x is 20 and y is 140, again the ratio is 1:7. Moving ahead, 3/210, the ratio remains 1:7. When x is 40 and y is 280, again the ratio is 1:7. So, we can say, see in the whole table, the ratio between the x axis and the y axis remains same, that is 1:7. Thus, we can say this table shows us the linear correlation between the two variables, that is x and y. If we are plotting this onto the graph, we will see that we will get a linear curve. We will see that it will give us a linear curve, and it is giving us a positive linear curve because it is going in the upward direction. It is also positive because we see that x is increasing and y is also increasing. So, they both are increasing in the same direction, and the ratio remains same between the two different variables for the product. So, they are called as a linear correlation. If I plot it onto the curve, I have this kind of a line which is called as a linear curve. Now, we have a non-linear or curvilinear curve in which the ratio between the two commodities, it might not remain the same. So, if the amount of the change in one variable does not bears a constant ratio to the amount of change in the other variable, then it give rise to a non-linear or a curvilinear correlation and a curvilinear line while plotting it onto the graph. For example, we talk about if we double the amount of rainfall, the production for rice might not double. So, the ratio, when the amount of rainfall is increasing, we take the amount of rainfall as onto the y axis and the production of rice onto the x axis and the rainfall onto the y axis. If I am plotting these two different variables for the production of rice onto the graph, then I see if the rainfall is increasing with time, we can see the production of the rice as it is limiting on after reaching a particular limit. We see here the production of rice and the production of rainfall. The amount of rainfall is increasing with a huge amount, whereas the production of rice is not increasing with the same amount. Thus, we can say that the ratio, they does not bear a constant ratio when we are talking about the change in the two variables. Thus, this gives rise to a non-linear or a curvilinear graph. The next comes to be the method of studying correlation. One is called as a scattered diagram. Scattered diagram, what is the meaning of scattered diagram means? When I am plotting a curve, when I am plotting two variables onto my graph, on x axis and y axis, what I have is, instead of getting a single line, what I get points which scatter in all the direction, but I cannot plot a single line. So, what happens is, the direction in which these points are going, the direction in which these points goes, we tends to plot a single line in that, in order to know what is the direction of the graph. So, this kind of scattering of the points, when we plot onto the graph, this gives rise to a scattered diagram method for studying the correlation. This very simple device, and we can plot, this is also called as a dot chart, and we can plot it onto a graph paper. by just looking at the dots, by just looking at the dots which we are plotting, we can find out as to the where these dots are scattered. In order to find out the correlation, just look, if we look at the graph, we can just find out which area the dots are being scattered, or which area the dots are being concentrated, and by looking at that only we can find out what kind of correlation the two variables, the things where x axis and the y axis which we want to study, we can find out. So, by just looking at the dots being plotted, it can be find out the greater the scattering of the plots on the chart paper, the lesser is the relationship, and greater is the closeness between the dots, the more is the relationship or more is the correlation between the two variables. When we have correlation is equal to plus 1, it is called as a perfectly negative correlation, whereas when the correlation, that is r, small r, it is represented by small r, it is negative, it gives you a very positive, perfectly positive correlation between the two variables. But if this correlation tends to be the small r is equal to 0, then it gives rise to a, there is no correlation between the two variables. That means, for example, if I plot my x variables and my y variables, the y says something like this and x says something like this. There are two different variables onto the x axis and y axis, and there is no reading which is giving a rise to some common points between x and y. We can have this kind of values, then there is no correlation between these points, and the correlation r is supposed to be 0 here. Now, there is one limitation when we are studying about the scattering method, that it only implies to two variables. We cannot study 3 variables or we cannot study 4 variables for any of the product. So, thus we can say that this is one of the limit, or we can say this is one of the limitation when we are talking about the scatter diagram, where only 2 variables are studied and we cannot establish relationship between more than 2 variables. The next comes the graphical method, where it is very simple device. Again, it has to be done onto the graph paper, but this graphical method, again, it does not establish a exact degree of correlation between the two variables. Thus, again, we limit our study when we are talking about correlation. We limit ourselves when we are talking about scatter diagram, and when we are talking about graphical method, we move on to more advanced and more technical techniques while finding out the correlation between the two methods. That is, one is Karl Pearson's coefficient of correlation and one is called as a rank correlation coefficient of correlation. When we are talking about Karl Pearson's coefficient of correlation, this is also called as a product movement method, where this method is also called as a Pearson product, because this was discovered by a scientist named as Karl Pearson. That is why we call it as a Karl Pearson's coefficient of correlation, or we simply call it as a Pearson's product movement. Thus, it is said to be, because it was invented by a scientist named as Karl Pearson, the coefficient of correlation computed in this method is known as the product movement coefficient of correlation, or Pearson's coefficient of correlation, which is represented by small r. While studying the correlation, we represent the correlation coefficient of correlation by small r, be it any method, but we represent it by small r only. The next fourth method which we study in order to find out the correlation between the relationship between the two variables is called as concurrent deviation method, or rank difference method, or rank coefficient correlation as well. In this rank correlation method, what we do is we find out what is the difference, or what we can say what is the priority, or how we rank different variables, how we rank different characteristics for any of the product depending upon my choice. We compare the ranks of 2 people, we compare the rank of 3 people, and we put this formula, we use this formula, the fourth one, the concurrent deviation method, or we use the formula rank difference method, and then we find out what is the relationship, what is the correlation between the different variables for the product. Just a small recap of what we have done till now is, correlation, the different kinds of correlation, the different methods of studying correlation. First of all, what is correlation? Correlation is nothing but the establishment of the relationship between two or more variables for a product is called as correlation. How much the degree of independence, interdependence between the different variables for the same product is called as correlation. For example, a very simple example, when we talk about price and demand for a commodity, when the price increases the demand goes down, or when the price decreases the demand also decreases. A simple correlation, simple relationship we can study by this example of price and demand. So, the degree of relationship which we are talking about between the two variables is measured under correlation analysis. This correlation analysis shows me the closeness of relationship between the two variables. Now, the measure of coefficient, the measure of correlation is called as correlation coefficient or correlation analysis. This correlation analysis is nothing but a statistical device which tells me what is the degree of association between the two variables. There are different kinds of correlation. One is positive correlation, where the direction of the change of both the variables is in the same direction, might be increasing or might be decreasing. Here these two, when the price is increasing and the demand is also increasing, this is called as a positive correlation, or we can say when the price is decreasing and the demand is also decreasing, it is also a positive correlation. Why? Because the direction of the change of these two variables are same, might be positive or might be negative. Sorry, not this one, might be positive or might be negative. Fine. So, what happens is, when we are talking about a positive correlation, the direction of the two variables has to be either going upward or has to be either going downwards, but the most important thing is it has to be in the same direction. The second is the negative correlation, in which the direction of one increases, one increases and the other decreases, or the one decreases and the other increases. That means, if the price of the commodity is increasing, the demand for the same commodity decreases, or if the price of the commodity decreases, the demand for the same product it increases. This is called as a negative correlation. We have studied the different examples of positive and the negative correlation by the help of graph. Then we have a simple partial correlation, then we have a simple correlation, partial correlation and multiple correlation. Simple correlation, when we study the relationship between the two variables. When we talk about more than two variables, it becomes the partial correlation, and when we are talking about the multiple correlation, we keep few variables constant. We think that they are not affecting the variable, they are not affecting the product. So, what we call it as a multiple correlation, although we are keeping in mind all the factors, but we study the production, for example, the production of rice in relationship to one or two variables, keeping in mind the other are constant. This kind of correlation, this kind of relationship, this kind of studies are called as a multiple correlation. Next becomes the linear and non-linear correlation. Linear one, when the ratio between the two variables remains constant, and when the ratio between the two variables throughout the series remains constant, and when we plot, we get a positive line. And when the relationship between the two factors, two variables, they are not constant and give rise to a curvilinear or a non-linear curve, it is called as a non-linear correlation. Next are the methods for studying correlation. One is called as a simple scatter diagram method. This second is the graph method. The third one is Karl-Pearson's coefficient correlation, and the fourth one is rank correlation, in which we put rank. The most successful today is Karl-Pearson's coefficient correlation and the rank correlation correlation, which we will be studying in the next further PPTs of the same lecture, of the same subject. Thank you so much.